Okay, for this problem we just need to use formulae. So we use formula for the length of the circumference. Length of the circumference is angle times radius, where angle has to be in radians. So this is just going to be pi over 6 times 3. So 3 pi over 6, which is pi over 2. So this is length of the circumference, pi over 2. Not circumference, length of this circular arc L, this curvy line here. For the second part, we need area. So remember, area for this curve, for this circular sector is the same formula as for the triangle. So 1/2 base times height, where base is this curvy thing that we just found, and height is the radius. So in other words, the formula is 1/2 angle times, because this L is angle times radius. So angle times radius for the base times radius for the height. So formula is 1/2 alpha r squared, and then you just plug in the numbers. So this is 1/2 times angle is pi over 6, and radius is 3. So I have this. So I have 9 pi over 12, and I can cancel this. So this is going to be 3 pi over 4, and that's going to be the final answer for the area of this segment. Okay, so next question is asking some proofs. So when we want to show an identity, what we can do first is transform this identity into something more manageable. Once we have it transformed into something more manageable, then we can look whether the left hand side is equal to the right hand side using some geometric identities that we know. So for part A, we would say, okay, let me rewrite tangent as sine squared over, let me write tan as sine over cos, and then I have tangent square, so I have to square these two. So I'm asking, is this equal to secant squared of 3x? Secant is 1 over cos, so I have 1 over cos, but that thing is squared. So I'm asking whether this is true. So it's equivalent to say, at least for an identity, so if I multiply by cos squared here, then I have sine squared of 3x, and that cancels the denominator, plus 1 times cos squared is cos squared 3x. Is that equal to 1? And that's yes. So true identity, because I have that this is equivalent to this, which is equivalent to this, which is true. So I know that, the true proof would really start from this equation. To be absolutely correct, one starts from the end and works back. One starts from a truth, then works back. So start with saying sine squared of 3x plus cos squared of 3x equals 1. This is true because this is Pythagoras theorem. And it's the fundamental identity of the trigonometric functions. And then you say, okay, I'm going to work in reverse. So what I'm going to do is I'm going to divide by cos squared of 3x. So I have sine squared of 3x over cos squared of 3x plus cos squared of 3x over cos squared of 3x equals 1 over cos squared of 3x. And then I'm going to rewrite some functions. So this first thing is tan squared of 3x. The second is just 1 And the third one, on the right hand side, I have sec squared of 3x. And that is what we wanted to show, so QED. Okay, so for the next question, I have sine cubed times cosecant is 1 minus cos squared. So sine cubed of x times cosecant of x equals 1 minus cos squared x. So always replace the non-sine and cos functions by their definition. So I have, this is sine cubed x times 1 over sine x. Is that equal to 1 minus cos squared x? Well, sine and the cube go away and I have only sine squared. So I have sine squared x. Is that equal to 1 minus cos squared x? And the answer is yes, because this becomes just sine squared x plus cos squared x equals to 1. In truth, I should be going back and working from the truth. So to be absolutely correct, and our proof needs to start with the truth, with an obvious truth. So we start with sine squared plus cos squared equals 1, and we work backwards. So that means that sine squared x is equal to 1 minus cos squared x. That means that sine cubed x times 1 over sine x is equal to 1 minus cos squared x. And then we can just replace. So sine cubed x times cosecant x equals to 1 minus cos squared x, which is what we needed to show. So QED. And that finishes the proof.